afternoon, everyone, and a warm welcome to our National Space Day webinar. I, Dr. Della Gisons, Associate Professor and Moderator for today's webinar, I am thrilled to be hosting the special event from DERT Studio, Shillong, an event which is being celebrated all over the country for the first time, marking the one-year anniversary of the Chandrayaan-3 mission successful lunar landing. This day honors India's achievements in space exploration and aims to inspire youth in STEM fields. Our session today promises to be an exciting and informative journey with insights from esteemed experts in the field. We'll delve into the significance of National Space Day, recognize the remarkable achievements of the Indian Space Research Organization, and discuss the various career paths available in space science. We'll share some thrilling ways for our dear learners to engage with the universe and spark our curiosity. So sit back, relax, and get ready to blast off into the world of space exploration. Let's make the most of our time together and ignite a passion for the stars. So get ready for a stellar event. And here's what in store for you today. Meet our experts, a warm welcome from our Director, Directorate of Educational Research and Training, mind-blowing presentations from our 5 distinguished experts, final thoughts from our experts, a heartfelt vote of thanks from our Joint Director, and the closing remarks from yours truly, your moderator. And now, put your hands together for our amazing experts who will share their insights on space exploration. We have with us here, joining from ISRO, Sri Ankush Kumar, scientist at Ahmedabad, who would be bringing the expertise of India's premier space agency ISRO to our webinar. Also, we have in our midst Sri Anjan Demnad from the Northeast Space Application Center, Shillong, who would share valuable insights on how space technology impacts our daily life. Along with us, we have Sri Donrich Khargongor, Assistant Professor, Department Physics, St. Anthony's College, Shillong, a leading expert who has been engaging with us in numerous programs. Another presenter who is here with us is Sri Rahul Chatterjee, Assistant Lecturer, Jail Road Boys Higher Secondary School, a space enthusiast, the educator extraordinaire. And last but not the least, we have Professor Ayan Bhattacharjee, Professor NIT Meghalaya, a renowned expert in smart and advanced materials. So let's get this event started and make it an unforgettable experience. But first, please join me in welcoming our director, Srimati Rimaya S. Manas, MCS Director, for the welcome address. So over to you, ma'am.
Thank you, Dr. Della. Good afternoon. I am Srimati R.S. Manas, Director of DERT. So a very warm greetings to all the esteemed guests, fellow space enthusiasts and participants joining us today for this webinar, celebrating the historic achievement of India's Chandrayaan-3 mission. It is indeed a momentous occasion as we come together to acknowledge and appreciate the incredible feat of our scientists and engineers who have placed India among the elite nations to successfully land on the moon. The successful landing of Chandrayaan-3 is not just a scientific triumph, but a symbol of India's growing prowess in space exploration. This webinar is a platform to delve deeper into the intricacies of this mission, understanding the scientific objectives, and explore the future possibilities that lie ahead. We are fortunate to have with us today a distinguished panel of experts who will share their insights and knowledge on this remarkable achievement. I therefore extend a warm welcome to all of you, and I am confident that this webinar will be an enriching experience for everyone. Let us embark on this journey of discovery together. Thank you.
Ma'am, we're so honored to have you lead us in setting the tone for today's discussion on National Space Day. Thank you, ma'am, for your presence, guidance, and valuable insights. It is our pride and our pleasure to formally introduce our first speaker, Sri Donrich Khargongor, Assistant Professor in the Department of Physics at St. Anthony's College. With his expertise in physics and passion for space exploration, he will take us on a journey to the significance of National Space Day, highlighting the importance of space research and India's remarkable achievements in this field. His presentation will cover the formation of the Indian Space Research Organization, notable milestones such as the Aryabhata, Chandrayaan, and Mangalyaan, and careers in space science. He will also share valuable insights on how to encourage our dear students to explore space and pursue careers in this exciting field. Please join me in welcoming Shri Donrich Kharkmore.
Thank you, Dr. Della, for welcoming me. And it's my privilege and honor to also share this panel with Professor Ayon Bhattacharjee and also with Shri Rahul Chatterjee. Hi, everyone. My name is Donrich Kharkmore, and I'll be giving a PowerPoint presentation on the National Space Day. And most of my presentation will be on the Space Research Agency, the Indian Space Research Organization, ISRO. So let me just dive in to the contents of what I'm going to say. So the slides which I'll be presenting will be on, let's say the first one will be why space exploration is important, and then the formation of ISRO. Then we can also see the major achievements of ISRO, and then the educational pathways to study space science if you're interested later on in your career, and what are the careers in space science. So let's dive in straight away. So why is space exploration important? Space exploration is important for understanding the universe and also for studying the other planets, and it can also help us to discover resources. These resources, which could be found in asteroids, could very well benefit industries here on Earth. At the same time, space research and space exploration is important because it can assist in the economic growth of the country in terms of generating jobs, in terms of defense, and in terms of research. Also, space exploration is important for observations can be carried on the Earth by studying its climates, its weather patterns, and also to mitigate the threats from celestial bodies that could impact the Earth. So with these things and aspects in mind, it is that our country, India, in 15 August 1969, formed the Indian Space Research Organization. The headquarters was in Bangalore, in Bengaluru, and it was established by India's first Prime Minister, Jawaharlal Nehru. This organization is under the direct surveillance of the Prime Minister of India. And currently in 2024, it is the 6th largest space agency of the world. We cannot forget the contributions of Dr. Vikram Sarabhai. He has been considered to be the father of Indian space research. And if you can see his quote out here, he said out here that if we are to play a meaningful role nationally, we must be second to none in application of advanced technologies to the real problems of man and society. So there are many achievements of ISRO over this course since 1969, but in this presentation of mine, I'll be highlighting only certain aspects. And these are few missions that ISRO had carried out that I will be stressing on. So the first one is the Aryabhata satellite. It was launched in 1975, and it was India's first satellite. It was named after the first Indian astronomer, Aryabhata himself. This satellite was completely designed and fabricated in India, and it was launched, however, in Russian soil. So the purpose of this satellite was to study experiments in X-ray astronomy and also to study the properties of the sun. So on that day, India became the only world's 11th nation to send a satellite into orbit. Now after that, we will move forward to the year 2008, where ISRO launched the next mission, the Chandrayaan mission, India's first mission to the moon. So this mission is basically an orbiter, and as you can see out here, for example, the Chandrayaan was launched, and we can see that the satellite moved in elliptical orbits with increasing radii, and eventually the trajectory led it to the gravitational field of the moon, where it eventually orbited around the moon. So this mission was important in the sense that it helped us to learn about the lunar surface, the chemicals composition of the moon surface, the minerals on the moon surface, and also the mapping of the moon. Now, the best finding for this mission was that it gave us evidence that water in the form of ice can be found on the moon surface. The next mission that I'm going to stress on is the Mars Orbiter mission, which is the MOM mission. It's also known as Mangalyaan. This is also another orbiter mission. But then out here we can see that it is the first venture, it's India's first venture into interplanetary space. The earlier Chandrayaan was that the orbiter was orbiting a satellite, the moon, but this time this orbiter was orbiting the planet Mars. So that was launched in 2014, and this makes ISRO only the fourth agency to do it. So again, the purpose is the same, it is to study the surface and the atmosphere of Mars. The next mission is Chandrayaan-2, and this mission is a highly complex mission in the sense that it is a great technological leap compared to the previous missions of ISRO. The reason for this is that this mission comprised of an orbiter, then a lander, and the rover. The lander was named Vikram, and the rover was named Pragyan. So this mission, it had an orbiter which orbited around the moon, and eventually a lander which landed on the surface of the moon. And the plan of the mission was to make a rover travel on the surface of the moon, just as a car traveling on a road. However, there was a software glitch, and the communication between the lander Vikram and the control station on the Earth was lost when Vikram lander reached an altitude of about 2.1 kilometers above the moon surface. So although the lander was lost, the orbiter, however, still sends back HD images to of the moon surface. The next mission will be the Chandrayaan-3. So we just found out just now that the Chandrayaan-2 failed in the final phase of its mission in 2019 just because it could not achieve a soft landing. However, this safe and soft landing on the moon surface by the Vikram lander was successful on August 23rd, 2023. So roving on the moon by the Pragyan rover was successful, and experiments were performed by the rover. So this makes this experiment very successful, this mission very successful for India, because it happened to be the first country to land its rover on the south pole of the moon. On the left, I show a picture that has been sent by Chandrayaan-3 as it was landing towards its surface, and we can see the dents out here. These happens to be the craters of the moon. So it's because of this reason that on 23rd August, which is today, that we are celebrating this National Space Day. So because it just commemorates the successful landing of Chandrayaan-3 on the south pole of the moon. And this year, 2024, marks the maiden celebration of the National Space Day in India. And we also remember Dr. APJ Abdul Kalam, who's the backbone of Indian space research. I would urge you students to kindly read his book, his autobiography, The Wings of Fire. Out there he stresses on the formation of ISRO and about his personal life history of the struggle to what he became who he is. So if some of you are interested to study space science, so it's very important that from high school that you concentrate on the science subjects like physics, chemistry, biology. So these are the basic sciences, and I urge you to build a strong foundation on these basic sciences, and also to develop some proficiency in mathematics, particularly in areas like calculus, algebra, and geometry. And of course, in this day and age, we need computer science. and learning of basic programming and understanding of computer science can be very beneficial for you. Then you can pursue your undergraduate studies, and of course your master degrees. You can pursue your master degrees and specialize on a certain specific area of interest, such as astrophysics or maybe planetary science or maybe astrobiology as well. And then you can continue with your doctoral degree, work on your research projects and your thesis, which can contribute to the field of space science. In my next slide, I can list out certain careers that you can carry out for space science. For example, you could choose to be an astronomer, or you could choose to be an astrophysicist, or an astrobiologist, which can help us to explore the potential for life beyond this planet Earth. You could also be a space lawyer, which could deal with issues like international treaties for space exploration among nations. Or you could also be a space medicine specialist by developing medical protocols for astronauts. And of course, you could also be an astronaut, train and participate in human flight space missions. I'll just mention a bit out here. We have our own space application out here, the center, NESAC, and it's located in Umiam in Meghalaya. It was established in the year 2000. So it's very close by to us, dear students, and I encourage you that this could be a good encouragement that you could find yourself to be if you're thinking to make a career later on in your lives. So this NESAC is operated under the ISRO, under this Indian Space Research Organization and the Northeastern Council. And it is a vital institution, especially for promoting sustainable development for our northeastern states out here. And this happens to be my last slide. So I urge dear students to be curious, to always gather knowledge, and you can only gather knowledge by reading good books. So gather as much knowledge as you can in all these years to come. I urge you to study the night sky. There are a few books out here that I've listed. These are good books where you can learn how to study the night sky. Be curious. You could visit planetariums. We have 2 planetariums nearby in the state of Assam. We have a planetarium in Guwahati, in Jorhat, and also in West Bengal, in Calcutta, the Birla Planetarium. You could also join online space clubs, and you could frequently visit websites on space research, just like the ISRO or the ESA or the NASA website. So these are the references that I've used for making this PowerPoint presentation. Thank you all.
Thank you, Sir Donrich, for that engaging and informative presentation. Your passion for space exploring is truly inspiring to the students, and we appreciate the time and expertise you shared with us today. Your presence has given us a deeper understanding of India's space program and the opportunities available in space science. Now our next speaker is Sri Rahul Chatterjee, lecturer at J Road Boys Higher Secondary School, who will discuss Aditya L1, India's mission to study the sun's corona. With his expertise in space research, he will share insights into the mission's objectives, significance, and implications for understanding of the sun and its impact on our planet. Please welcome another expert and space enthusiast, Shri Rahul Chatterjee. Over to you, sir.
So my presentation today would be on Aditya L1 in particular. And this is a pride project of ISRO, while Chandrayaan is a demonstration of technology. The Aditya L1 is a purely scientific project. So let's see why ISRO needs to have this project and what are the main aspects of Aditya L1. And as we go along, we'll explain certain terms that come across when we talk about Aditya L1. So Aditya L1 is our first satellite that is studying the sun. Aditya means sun, or the newly risen sun, or the Lord of the sun. It is India's first spacecraft dedicated to studying the sun. But the question is, why is it so important to study the sun? and what aspects of the sun are we studying through Aditya L1? So here you can see the launch of Aditya L1 using the PSLV C-57. It's an indigenous launch vehicle, and that is something we are very proud of. And it was on 2nd of September 2023, very close on the heels of the successful landing of Chandrayaan-3 on the lunar south pole. So there were two very successful projects, one after another, performed to copybook perfection. Both these successes put India on the global map of the reckoning with the technology and the science that is involved in both of these. The world, as it were, sat up and took notice, and there were congratulatory notes that came from all over the world. So, after a long journey of 126 days, Aditya L1 was placed in a halo orbit around L1 on the 6th of January 2024. I know there are two terms over here that you probably don't understand, L1 and halo orbit, so I'm going to talk about those. So, L in L1 stands for Lagrange, after the Italian mathematician and physicist Joseph Louis Lagrange, who lived from 1736 to 1813. So these are the 5 Lagrange points. As you can see, that is the sun, that's the Earth. The blue orbit that you see is the orbit of the Earth around the sun, and this red orbit is the orbit of the moon around the Earth. L1 is a point here which is beyond the orbit of the moon, and L2 is here, and again you can see L3, L4, L5. Now here I've put in the distances. Earth-Moon distance on an average is 3,84,400 kilometers, whereas the Earth L1 distance is about 15 lakh kilometers. So clearly you understand that if we put our satellite at L1, it is way beyond the orbit of the moon. So no lunar eclipse can happen. Nothing is in the path of our satellite Aditya over here. It can study the sun absolutely unhindered and pass on the information directly to the Earth. But what are these points, L1, L2, L3, L4, and L5? These Lagrange points are special points where the gravitational field due to two massive bodies, 1 and 2, the gravitational field due to these two massive bodies allows the inclusion of a smaller body at this point in such a way that the centripetal force required for this body here to move around a circular path is exactly equal to that of the Earth. Now, if you didn't follow that, I'll make it a little simpler. Let's look at this slide first. So this is the solar system. Here's the sun. Mercury is the nearest planet, and it has a time period of 88 days. Venus has a time period of 225 days. It's slightly outer than the Mercury. Earth has 365.25 days, and this way if you keep going outwards, you will see Neptune has a time period of 164 years. What I'm trying to drive at over here is the nearer the planet to the sun, the smaller is the time period of rotation. The farther the planet, the longer is the time period of rotation. That's what we can see clearly. So here, if you look back at this Lagrange points, L1 is closer to the sun than the Earth is, and so it should have a time period shorter than that the Earth has, but it has exactly the same time period as that of the Earth. So as the Earth rotates along this orbit, our Aditya L1 will also move along with the Earth, and therefore both will be in sync with the sun and pass on information directly wherever it is. But the orbit is not straightforward. When we put any smaller object in this in any of these Lagrange points, we say it takes a halo orbit. So what's a halo orbit? So look here. So this is how we launched the satellite from the Earth. With PSLV, we launched it to a certain height, and then there were rockets in the satellite itself, which we fired at opportune moments to make it go higher and higher, and finally give it the velocity, actually escape velocity, to escape the gravitational pull of the Earth and move to a point where, again, if you fire certain rockets, then it goes into the halo orbit. It reaches here 1.5 million kilometers away from the Earth towards the Sun. At present, just curiosity's sake, I mean, nothing to do with Aditya, at L2 we have the James Webb Space Telescope. So let's continue with what we're doing. So here, while it is at L1, it really goes around in a halo orbit circling L1 as it moves forward and circles around the Sun. That is what we mean by a halo orbit. So let's move forward and look at other things. So what are the payloads with Aditya L1? Here's a table of the different payloads. Here we have, if you can see, there are two classes of payloads. We have the remote sensing payloads and we have the in situ payloads. In the remote sensing payloads, we have 4 of them. They are the visible emission line coronagraph, VELC. What does it do? It studies the corona, images it, and does a spectroscopic study of the corona. Why that is important? We'll see just now. Then we have the Solar Ultraviolet Imaging Telescope, SUIT, and it studies the chromosphere in the ultraviolet range, also the photosphere. Then we have 2 instruments studying the X-ray output of the Sun. So that means the Sun also gives off a lot of X-rays, and you will see that this year particularly the Sun is giving off a lot of X-rays. I'll explain that. So we have that. Then we have the Solar Wind Particle Experiment to study the solar wind particles. Here we have the heavier particles like protons, and then we have the lighter particles like electrons as well. And finally we have another instrument to study the in situ magnetic field of the Sun. So here is the visible emission line coronagraph meant for studying the corona. We'll talk about the corona just again. And here's the Solar Ultraviolet Imaging Telescope meant for studying the photosphere and chromosphere. Here the X-ray spectrometer. This is the hard X-ray, the previous one was the soft X-ray. And here are the plasma analyzers. We have actually 2 instruments over here for plasma analysis, and rather for solar wind analysis, and this one is for the plasma analysis. And this one is for studying the in situ magnetic field in all the 3 axes, X, Y, and Z axis. B stands for magnetic field. So the question is, why do we need to study the Sun in all these aspects? What is so important about it? So let's start with the solar corona. The solar corona is a faint region on the outer side of the Sun, way beyond the surface. We cannot see the solar corona unless there is a total solar eclipse. So what Aditya L1 does is creates an artificial solar eclipse and then studies the corona. Why? Well, the surface temperature of the Sun is around 5,000 degrees centigrade, but the temperature of the corona is around 2 million degrees centigrade, which is farther away from the surface. And I thought if you walked away from a hotter body, then the temperature should fall. Now there is something that we need to understand. There is some kind of a puzzle over there. We are moving away from a hot body, but the temperature increases. So that's something we need to understand. Moving further, let's understand the solar cycle. The Sun has a 11-year cycle. Every 11 years, solar activity peaks to a maximum, and it happens to be this year, the 25th solar cycle, since we have been measuring from 1755, keeping records rather from 1755. This is the 25th solar cycle, and this is 2024, and we are peaking around October, September, October. Already we've had some massive solar storms hitting the Earth, and we could be having a few more. So when we say solar activity increases, what kind of solar activity really increases? Particularly what increases are magnetic activity and X-ray activity. And as you can see in this little animation, what we are trying to show you over here is a huge magnetic loop. These magnetic loops are always present on the surface of the Sun, but they increase in huge numbers during solar maximum. And sometimes, because these magnetic loops have a lot of tension in them, they twist and turn, they break like this. And along these magnetic loops, charged particles from the surface of the sun fall back onto the surface of the sun. Normally, that's what is supposed to happen. And charged particles, because the sun is made up of plasma. But then when these loops break, then these charged particles fly out into space, and if the Earth is on the path of these charged particles, then we have what we call a geomagnetic storm. And we'll come to that later. So here are 11 suns for 11 years. Look at these yellow spots over here. These yellow spots show magnetic activity, and the red glow all around shows the X-ray activity. So you can see at solar maximum, the amount of X-rays that are given off by the sun are huge, and a lot of magnetic activity goes on. So as it goes down the peak and solar activity decreases, you can see clearly how both X-rays have almost reduced over there to 0, and there is almost no magnetic activity. And then gradually in 5.5 years, again it will peak, and this is where we are in this year, in 2024. And again, 11 years later, 2035, 35, 36 are going to be peak years again. So moving on, here is a solar CME, coronal mass ejection. So I said that during these peak years, a lot of magnetic activity and X-ray activity happens, and I showed you earlier that one of those, in that animation, that let me go back. Yeah, in this animation, you can see the CME breaking open, and this is just an animation, but the real one is this. But of course, this is played very fast. So again, to be able to see all this, we have created an artificial solar eclipse. We've covered the disk of the sun so that we are able to see this, and of course, this is played very fast. A lot of a few hours of activity played very fast, and you can see these charged particles going to huge distances. If this is the size of the sun, they are going way beyond some 7, 8, 10 times the distance of the size of the sun. So it's naturally covering the Earth and some of the outer planets as well. And these little streaks that you see, these are proton hits on the camera. So these charged particles, they come and hit the camera. So if this was towards the Earth, then certainly they would have hit the Earth. So this is the animation of that, and I told you what is a geomagnetic storm. So suppose one of these CMEs break open and the charged particles happen to fly towards the Earth, then we have what we call a geomagnetic storm. And in that case, the magnetic field on the side which is facing these charged particles, they get squished like this, and the other side elongates. But thank God for the presence of these of the magnetic field. These charged particles cannot hit the Earth directly, and we are kind of safe. Else, life would not have been possible on Earth. If any life had happened, ultimately they would be killed, so to speak, destroyed because of these charged particles. So let's watch this video, and what we want to understand through this video is what really happens, or how Earth is affected when a geomagnetic storm hits the Earth, particularly in today's world of technology, satellites, and everything electronic. Let's watch this. While the sun has always been a source of energy for us, it has also been a source of awe and wonder. But did you know that it can also be the source of something dangerous that can greatly impact our daily lives? We are talking about solar storms whose frequency increases drastically during solar maximum. Solar storms are intense bursts of energy from the sun that can travel millions of kilometers through space and hit our planet. Solar storms occur when the sun releases huge bursts of energy in the form of solar flares and coronal mass ejections, or CMEs. These phenomena send a stream of electrical charges towards the Earth at a speed of about 5 million kilometers per hour. Were it not for the protective magnetic field around the Earth, these charged particles could destroy all life on Earth. A solar flare is a sudden burst of energy from the sun's surface, while a coronal mass ejection is a huge cloud of charged particles that is released from the sun's corona. Scientists can predict when solar storms will occur, but they can't accurately predict the severity of the storm. The most severe solar storms can cause widespread power outages. Power grids are particularly vulnerable to solar storms. The electromagnetic radiation from a solar storm can induce electric currents in power lines, causing transformers to overload and potentially cause widespread blackouts. They can disrupt communication systems and damage satellites by overloading their circuits with a deluge of charged particles. In 1859, the largest solar storm on record, known as the Carrington event, occurred. It was so powerful that it caused telegraph lines to catch fire and created auroras as far south as the Caribbean. If a similar event were to occur today, it could have catastrophic effects on our technology-dependent society. Imagine what would happen if the internet was disrupted across the country, banking, the stock market, railway reservation and functioning of the railways, air travel, defense, government functioning, entertainment, everything would be severely affected. Life would come to a standstill. If satellites get disrupted, GPS, remote sensing, entertainment, communication, all would be disrupted. Even wars would be affected as guided missiles use GPS. We cannot afford such a catastrophe upon us. We have to be prepared. What is more, India has a rich array of satellites for different purposes, including our own GPS abbreviated as NAVIC. All these national assets are endangered by the solar storms. This is where the role of Aditya L1 comes in. It will help us unravel the secrets of the different solar phenomena, enabling us, perhaps, to guard our assets in a better way and contribute to furthering human knowledge so that it benefits all of humankind. While solar storms can be dangerous, they also create beautiful auroras in the sky. Auroras occur when charged particles from the sun collide with particles in the Earth's atmosphere, creating colorful displays in the night sky. Solar storms are a reminder of the power of nature and the importance of being prepared for the unexpected. By studying solar storms, we can better understand the sun and take steps to protect our technology and our way of life. The Aditya Solar Wind Particle Experiment, ASPECS in short, and the Plasma Analyzer Package for Aditya, PAPA in short, are payloads specifically designed to study solar storms to be able to ultimately protect our electronic technology, which is the backbone of modern society. So there you are. Now you can see why we needed these instruments. We need to understand why the corona is so much hotter than the surface of the sun. We need to understand the emission of the ultraviolet rays from the sun. We need to understand the X-rays, how much of X-rays are being emitted from the sun. The particles, particularly because they affect so much of our technology. And so you see, these 7 instruments have been carefully chosen so that we can keep our space assets in safety. Thank you.
That was really wonderful, sir. We appreciate your valuable insights, and your presentation has shed light on the exciting development in space research and the importance of studying our amazing sun. Thank you, sir, for sharing your expertise with us and also inspiring us to learn more about space. Now, at this time, it's our pleasure to introduce Professor Ayon Bhattacharjee. He is a professor at NIT Meghalaya, who will enlighten us on the development of engines for rockets. With his extensive expertise in aerospace engineering, he will share insights into the challenges, innovations, and advancement in rocket engine technology. Please join me in welcoming our esteemed Professor Ayan Bhattacharjee from our very own NIT Meghalaya.
Yeah, thank you, Dr. Della, for your introduction. And it's wonderful listening to the talks from Sri Donrich and Mr. Rahul Chatterjee. And you have seen there in both the talks about the Chandrayaan and the Aditya that the satellite has to be placed in a particular orbit. So my talk focuses on that. We are all awed by the success of Chandrayaan, the success of Aditya mission. But behind that, if we look into the how the entire launching takes place, just think, you are playing golf, but the hole is about a kilometer away, and the hole is moving in some direction, and you are on a car. The car is also moving. So with that kind of a precision, you have to put that golf ball into a particular hole. And another level of challenge that is added up is that the ball can only spin, but it cannot rotate in a vertical axis. Okay? What I mean to say, a satellite can spin, a satellite can never tumble. The moment a satellite tumbles, it gets destroyed. Now, going back to the history of ISRO, as Sir Donrich had shown, it all started in 1969. And in 1970, we started sending these sounding rockets. So sounding rockets are very elementary kind of rockets that can take a small payload to around 70 kilometers to 150 kilometers and so on. And initially, ISRO started using rockets which were imported either from France or from Russia. And slowly, with that technology in mind, ISRO started developing the rockets, and they ended up with the Rohini satellites. With Rohini, ISRO could reach altitude of around 450 kilometers, and it could take payloads up to 100 kg, 150 kg, and so on. And then ISRO seriously started thinking of having its own launch vehicles. So the first launch vehicle that was developed is the SLV, Satellite Launch Vehicle. So there were various versions of that launch vehicle, SLV 1, 2, and then came SLV 3. And then around the 1980s, we had something which is called the Augmented Satellite Launch Vehicle. So as you can see in the slide here, SLVs were single rockets. When we had the Augmented Satellite Vehicle, then it had strap-on rockets. So there was a central rocket, and it was connected to 2, 3, 4 other rockets which would help in the launching process. And that way things progressed. Then slowly ISRO could develop what we call the PSLV, the Polar Satellite Launch Vehicle. Now that was a milestone for ISRO, because this became our workhorse. Most of the satellites ISRO sent was using this system, Polar Satellite Launch Vehicle. Okay. And then slowly we started sending the geostationary satellites. So they were the INSET series of satellites that we all know. They started the communication revolution in India. And now we have this LMVs and SSLVs, Okay, these are much smaller than GSLVs, but they are powerful enough to take the satellite to the orbit. Now, the satellite technology, when we see, it's a combination of various things. What America did, what NASA did with a lot of power, India tried to do with some intelligent thoughts. So, this is the trajectory of the Chandrayaan, or even the Mangalayaan, we use the same kind of trajectories. Okay. And this is what we call the slingshot. So, since India did not have very, very powerful rockets, what India did was it took the rocket to a certain height, and then it had booster satellites which kept on elevating it and making the orbit bigger and bigger and bigger, and ultimately it came out of the Earth's influence, Earth's gravitational influence, and as soon as it left the influence of the Earth, it was little guided through these booster satellites to the orbit of the moon. Then again process of slowing down started. Okay. So, this whole method, we saved a lot of energy, and that is why you will find a lot of people saying that India sent a satellite at the price of a rickshaw, auto rickshaw fare. Okay. So, that is where Indian technology overcame many of the hurdles. Then yeah, this is the trajectory which I can show in a much simpler way. Okay. So, this is what we have in the this is the lunar trajectory, and this is the slingshot method that we have used. Okay. Now, to send a rocket to space, the most important thing that we need is the engine. Initially, India started getting some engines from Russia, but India wanted to develop its own engine. The first engine that I have shown here in this slide, it is called the Vikas engine, V-I-K-A. So, yeah, V-I-K-A-S. So, Vikram A. Sarabhai. So, the initials were taken from his name. Now, this is a solid fuel engine. We have two solid propellants. These two solid propellants are mixed together, and it can give a thrust that can send the rocket upwards. A very small experiment can be done at home. If you take a little bit of potassium nitrate and you mix it up with sugar, and both should be very finely grinded, and if you light it up, you will see that it burns with a very vigorously. So, that if it can be channelized in a small cone, the thrust can be achieved. So, ISRO made this engine. Now, if you look into the story of the Vikas engine, it all started with an engine made by German prisoners. So, somehow India got because satellite technology, rocketry and missile technology are very well connected. So, no country wants to give its technology to anyone else. So, India somehow India collaborated with Russia, they got this German engine and they started developing it. And then what happened is the first engine, it was developed in France. So, once this satellite, this engine was developed, it was under Nambi Narayan, the scientist, and this cost India about 1 crore, which is much cheaper than any other engine which was available at that time. So, he faced a lot of hurdles and somehow convinced the government of India to give him the funds. So, he could launch the small dummy satellite, from France itself, because India did not have a launch pad at that time. Later, he could it was fully developed and it became the main engine of the Indian satellite program. So, even now all the satellites which are strapped on, they are all based on the Vikas engine. Then what happened is the cryogenic engine. India needed a cryogenic engine because solid propellants were very made the satellite the whole system very heavy. So, cryogenic engines basically use hydrogen and oxygen to generate the thrust. Now, what happened is India in 1982 first decided we will make a engine, but it was facing a lot of bottlenecks and they stopped it. Then the thought of importing the engine, initially from Japan, it did not work out. Then from US, this General Dynamics Corporation, they wanted an engine and also approached Europe Arianespace. But the cost was about 1,000 crores, which was very high at those times. Russia offered something at around 300 crores. But the moment the Russian started giving the engine to India, America put some sanctions using this missile technology control regime, MTCR, and the non-proliferation treaty, and they stopped the whole thing. Okay. But then India continued. Secretly Russia helped it, helped the program, and slowly they could develop the engine, and that cryogenic engine has become the main engine for all the GSLV rockets. Okay. Now, if you want to know more about this, there is a book called Spies from Space, the ISRO frame up. That is a very interesting book on this subject. Now, this is the cryogenic engine that we can see, and this cryogenic engine is the mainstay for the satellite program now. So, if you look at this figure, you can see how this engine functions. So, there are two. LH2 is the liquid hydrogen container, LOX is the liquid oxygen container. So, they will carry the liquid oxygen and liquid hydrogen together, and they will fire it up in the area marked in red. And then below that we have the cone. So, through this cone the entire thrust comes out, and that is what puts the rocket into the it takes the rocket into the orbit. And the same thing I have tried to show it in the whole rocket here. If you can think, Chandrayaan-2 is a very small module compared to the entire size of the rocket. We are used to buying small trinkets from Amazon. Pen worth 10 rupees can be transported from Mumbai to Shillong, but think of the process. The pen is shipped by train or aeroplane or jeep or bigger vehicles. But since they club everything together, we never think of the delivery. But ISRO has to think of that. We have to put a very small satellite into space, but to take it there, and with the precision that I was discussing right at the beginning of this talk, it becomes a very difficult process. So, this is how it is done. We have different stages of the satellite, and that is what propels the satellite into its orbit. Okay. And again, if we look at the satellites themselves, Mr. Donrich had talked about the Aryabhatta. Then we started with Bhaskara and Apple. These were the smaller satellites. But look at the resolution. The resolution at those times were about 1 kilometer, and they had a single transponder. Transponder are the devices that communicate between Earth and the satellite. Right now, the modern satellites that we have, 317 transponders. So, every transponder corresponds to certain information, and 0.28 meters resolution, 28 millimeter. So, basically we can identify your face from the space.
28 centimeters.
Yeah, 28 centimeter, yeah. So, we can identify your face from the space. So that is the resolution we have now. So with that, India is progressing. Okay, and Chandrayaan 1, 2, and 3 are done. India has already the vision ready for Chandrayaan 4, Chandrayaan 5. We are ready with Gaganyaan. Navik is already in space, and Navik is very important for us these days. In Kargil war, GPS was used, and America did not give us all the locations. Now, because of Navik, and Navik's precision is much better than GPS, and from next year, all Apple phones will use Navik instead of GPS. So, we are really moving forward very fast. So that's our pride that ISRO is there. Now, coming back to what we can do as students, Donrich had given a very good idea. Okay, so students from any field can go into space technology these days. My research is mainly into smart and advanced materials, but we need students from backgrounds like geography. Navik does not work without geography. It does not work without proper mathematics, computer science, of course. Then there's a lot of biology involved when we study the biological aspects of space. So any field you are in, even management, humanities, everything comes in together. Okay, so that's a wonderful opening that the youth of the country has. So with that, I'll just end my talk. But I would like the students to take this opportunity, go to the ISRO website and look into things that how can they fit into the space program of India.
Professor Ayan Bajitaji, your presentation was truly enlightening. Your expertise in rocket engine development is really impressive, and we thank you for sharing your knowledge with us. Your insights has given us deeper understanding of the complexities and the innovations in rocket technology, which will inspire our young learners. Now let's move on to the exciting topic of Chandrayaan-3. It's our privilege to have in our midst Shri Ankush Kumar from ISRO. We invite you, sir, to share your insights on India's recent lunar mission, Chandrayaan-3. This mission marks a significant milestone in India's space exploration journey, and Sir Ankush will take us through its objectives, achievements, and implications for future space research. Please join me in welcoming Sir Ankush as he takes us on a fascinating journey to the moon.
Namaste, my name is Ankush Kumar. I am working as scientist engineer in Space Application Center, SAC ISRO, Ahmedabad. I will be discussing about the India's Chandrayaan mission. We have launched 3 missions for the moon studies, that is Chandrayaan 1 in 2008, Chandrayaan 2 in 2019, Chandrayaan 3 1 year before in 2023. So let us know about the visionary of Indian space program. As we know, Dr. Vikram Sarabhai, known as the father of Indian space program, he has initiated the space-based activity in India. And along with him, Dr. APJ Abdul Kalam sir helped a lot. And we have Professor Yashpal as the first director of Space Application Center, SAC ISRO, Ahmedabad. Indian National Committee for Space Research had been formed in 1962, where initially or officially the space activity started. Then Thumba Equatorial Rocket Launch Station established in Thiruvananthapuram, Kerala, where the small rockets were launched, and that activity of space research and development initiated. In 1969, Indian Space Research Organization ISRO has been formed, and initial Indian space activity started in a church. Thanks to them, and today we have this as a very good space museum. And initially small rockets called sounding rockets were launched. Today also these type of rockets are being launched. These rockets are for studying the atmosphere and various parameters with height, and subsequently SLV-3 rocket, which is bigger version of these rockets, were developed. And now we have various bigger rocket available with us, that is Polar Satellite Launch Vehicle, PSLV, which was used in Chandrayaan 1 launching. We also have GSLV and GSLV Mark II and GSLV Mark III, which are used for typically launching the geostationary satellite in 36,000 km altitude. JSLV Mark III or LVM rocket also used for the launching of Chandrayaan 2 and Chandrayaan 3 missions. We have launched various satellites for Earth observation studies, communication, navigation applications, lunar mission, interplanetary mission, and space mission. For Earth observation, it is used for society or societal benefits. For example, predicting the crop forecast and helping the fishermen for telling them about the location of a good fish catch, tracking the cyclone and providing the forecast of where cyclone will go so as to save the human lives. Now, Indian moon missions, we have Chandrayaan 1, 2, 3. They follow a similar trajectory initially, that is, after the launch, where launch vehicle put the spacecraft in the orbit around the Earth. Then there were various engine burn which increase the orbit around the Earth, making it more and more elliptical. Then in final orbit, we have final burn which takes the spacecraft from Earth to Moon through an orbit called lunar transfer trajectory. Now, after reaching near to the Moon, the spacecraft had been captured in the gravitational field of Moon into an elliptical orbit. Then after engine burn, elliptical orbit becomes less and less elliptical, and then finally circular orbit is achieved, further which can be used for landing in the mission like Chandrayaan 2 and 3. In Chandrayaan 1, there were various scientific instruments. Those instruments were from India as well as some from the international space agencies. One of the major discovery of this mission is that Moon was thought to be dry before this mission. After this mission, the scientific instrument detected the water on the Moon, and subsequently the paradigm shift is there in terms of the scientific investigation on the Moon. And based on this, further scientific missions, which are the lander missions, are planned. ISRO planned Chandrayaan 2 and Chandrayaan 3 as the orbiter lander mission. In Chandrayaan 2, we have the orbiter with good scientific instruments, Vikram lander and the Pragyan rover. In Chandrayaan 2, we have a very high resolution camera, OHRC, which is called orbiter high resolution camera. It is used for imaging the very fine details of the Moon surface, which are used for landing Chandrayaan 3 lander, as well as it is useful for the international landing missions. In this image, we can see the Apollo 11 lander has been imaged by this camera. Very nice image has been captured. Now coming to Chandrayaan 3, Chandrayaan 3 is a very complex mission. We have to land in near South Polar region, where the very small portion of the region is there which is very safe. Otherwise, there are a lot of craters, boulders, and it is very hard to find the good place for safe landing. Now in Chandrayaan 3 mission, the aim was to safe and soft land on lunar surface, to demonstrate the deployment of the rover on the Moon surface, and to carry out the scientific instruments. So in which we had one propulsion module which take the lander craft from Earth orbit to the Moon, and also subsequently lander carries a rover which will be deployed on the Moon surface after subsequent landing. Lander craft carries various sensors which are essential or useful for the safe and soft landing. These are altimeters measuring the height, velocity meter measuring the velocity, inertial system measuring the attitude or the orientation of the spacecraft, propulsion system reducing its velocity during the touchdown, during the descent phase till touchdown, navigation, guidance and control system, which is the brain of the total system, which is guiding thruster taking the input from various sensors, and hazard detection avoidance system, the important sensor which SAC provided, useful for the finding out the final suitable landing location for the final descent. Now on Chandrayaan 2 lander and rover, we have several scientific instruments which are useful for example on the lander for the measurement of electric field, temperature beneath the soil, seismic activity on the Moon, and retroreflector. On rover, we have the alpha particle X-ray spectrometer and the laser induced breakdown spectrometer, which were useful for finding out the composition of the soil, like what are the elements available there. These are the glimpses during the launch of Chandrayaan 3, which was launched on 14th July 2023 and landed on 23rd August 2023. It was a very good success. Space Application Center, Ahmedabad contributed significantly in Chandrayaan-3 mission in terms of providing the various camera which provided visuals during the landing, as well as crucial instruments which were useful during the landing. For example, hazard detection and avoidance camera, where it provided during the hovering phase the final safe landing grid or landing location where lander has to land, as well as the curve and radar altimeter which provided the height information during the landing. So these were very crucial for the landing of the Chandrayaan-3. So this is the trajectory from 30 km to touchdown. This take place under the automatic landing sequence activity where no commanding is possible from the ground, and the lander has to land based on its own intelligence using the various inputs from the various sensors and using its onboard computer and thruster. So at different altitude, like for example 7 kilometer altitude, various sensors operated, like for height measurement, velocity measurement, and at 150 meter navigation based on the vision or the imagery took place, where vision camera provided the safe landing grid for the final vertical descent phase. These are glimpses after the soft landing of Chandrayaan-3. There was a moment of joy and proud. It inspired the whole nation. It was a very good event and very great event. Post landing, Chandrayaan 2 orbiter OHRC confirmed the position of the lander craft by imaging. After that, there were various scientific studies carried out in which different sensors, scientific instruments provided various data about the moon. That few of them are that temperature on the moon surface drop very fast beneath the surface. There were various elements present at the location of landing, and sulfur was detected there. Seismometer detected various seismic activity, including the seismic activity which is created during the motion of the rover. This is just a view graph in which we can see lander and the rover, a representation purpose. Now these are the visuals. On left we can see when rover roved and moved to a little far place from the lander. It has captured the image of the lander there, and few of the scientific instruments which were deployed from the lander onto the moon surface were also seen. And on the right side we can see the deployment process of the rover, and after deployment rover reached a little far distance. So this is a very critical event, and we have with this a very great mission accomplished. So this made all Indians proud nationally as well as across the globe. Thank you very much.
Thank you, Sir Ankush, for that insightful presentation on Chandrayaan-3. Your expertise and passion for space exploration are truly inspiring. We appreciate your time and knowledge, sir. Your presentations has given us a deeper understanding of India's lunar mission. And now please join me in welcoming Anjan Debnat from North East Space Application Center. Mr. Debnat, who is a scientific engineer, brings a wealth of expertise in space technology and its application. And today, he will share his insights on a topic relating to space application on NISEC's initiatives. His presentation will highlight the importance of space technology in specific areas of focus, which is environmental monitoring, disaster management, or rural development, and other things which are related to our various subjects content in the school. Let's welcome Mr. Anjan Debnat and explore the exciting possibilities of space application in the northeastern region.
Thank you for this session, and I welcome all the participants who are joining today for this National Space Day celebration. So this is the first anniversary of India's successful landing on near the southern pole region of the moon on 23rd August of 2023. So on this auspicious occasion, we will be presenting to you a brief, in my lecture at least, I will be presenting to you a brief about the specialties of the moon mission, that is India's lunar mission, and also I will be telling in brief about the activities that my center, that is Northeastern Space Application Center, is doing for the Northeastern region. So I will be starting with India's moon mission, and we will be going forward. Okay. So why is the moon, and why we have chosen the moon especially for this moon missions? The major reason is that maybe from Chandrayaan-1 mission, if you can remember, there was a huge buzz in the media that India has discovered water on the moon, and water, as we know, is the bed for where all the life form is originating. So for all the life to exist, we need water, and on moon there was a first possibility of finding water, habitable water, and that also so close to Earth. As we know, moon is the only natural satellite of Earth, and so it is very close to Earth, though it is almost 3.84 lakh kilometers away from Earth, but still it is closer than any other planet. And there, if we can find water, and also I think all of you know, then there are global initiatives for settling in some extraterrestrial planet, maybe some other planet if it is habitable. So as we can see, the moon atmosphere, it is somewhat close to what Earth atmosphere is. It can be made habitable, but only if we can get water. And if the Chandrayaan-1 mission was finding water there, as you can see the reasons, so it is very close to Earth and water is available, there was a chance of detecting water. So all the scientists all over the world, they were very thrilled. And actually before the Chandrayaan-1 mission also, there were so many missions for landing on the moon, because it is the closest to us. So all our space exploration for all the countries, we can say it started with the moon. Okay. So going forward, this slide, I will just try to show you a little brief about the comparison between Earth and the moon. As you can see in the right hand side, the distance from Earth and moon is almost 3.84 lakh kilometers. It is actually very far, but it is the closest to our Earth. And the first thing, if you see the gravity parameter, the gravity on moon is 1/6 of Earth. So basically what does that mean? That means if we jump on moon, we will go further up, and we will feel less pull towards the Earth in moon. So that is one thing that is a little bit changing, and otherwise moon is, we know, very small, and the mass is also very less. If you can see the mass and the mean diameter, you can see that the moon is actually very small and also very light. Actually that light mass is only giving it less gravity. So that is the main reason why we are looking forward to putting our colonization, or for those reasons as a moon, because it is somewhat close to Earth and it is very close to also Earth. Okay. And now we will be going forward to what is India's moon missions. What are the 3 attempts that India have made till now for reaching the moon? See, actually all the other countries are trying, like from the America and Russia, they actually started. Russia was the pioneer, we can say, with their Luna missions. They tried to impact the moon surface, and they also tried to orbit the moon and also land on the moon. On all 3 occasions, they were very much on the course, but then America was the first country which could land a human being on moon surface. That is through their Apollo missions, and Apollo 11 mission was the first mission which could land human beings. As you all know, very famously Neil Armstrong, and those people were the first people who landed on the moon surface. But India's effort started, some can say it is very late, but it is not that late, because India's at the time where America and Russia, they were trying in the 60s and 70s, that time India was still struggling and was a developing nation. So our first priority was for our nation's development in financial and other food security and other aspects. And space exploration, though it was very interesting and very important also, but it only started around that time. So we needed some time to develop ourselves, and then slowly around 2008, the first Chandrayaan-1 mission came. In the first Chandrayaan-1 mission, it was 22nd October in 2008 was the historic day when Chandrayaan-1 was started its journey. And then what was its basic idea? It was basically an orbiter, means it will go near moon and move around the moon. So this orbiter was the Chandrayaan-1, and it could take, and what is the benefit of orbiting? The benefit of orbiting is that it can take pictures. So Chandrayaan 1 took beautiful pictures of the moon, and also from this Chandrayaan 1 mission, we could, because of these images only, we could understand and we could infer that there may be crystal water in the moon, in the polar regions. So emboldened by these efforts, in 2019, Chandrayaan 2 mission started. In Chandrayaan 2 mission, which was in 22nd July, see the dates are very similar, it's 22nd October and 22nd July. Chandrayaan 2 mission, this mission was a proper full mission. Here there was one orbiter, there was also a lander and a rover. So the lander was named Vikram and the rover was named Pragyan. And this whole mission was supposed to reach moon, move around moon, and then the lander and rover was supposed to separate from the main module and then land on the moon, and then the rover would come out from the lander itself and then it would walk on the moon basically. So this was the whole idea. Okay. And then from this Chandrayaan 2 mission, as we all know that this mission actually failed. We would not directly say that it failed, but in this mission the two basic ideas, that is the lander and the rover, those were not realized, because what we intended to do is a soft landing. See, whenever a exploratory object or a spacecraft goes near another object, like in moon, we are saying from Earth to moon, there is a huge distance and we need to go very fast. And for moving around moon also, it needs humongous speed. So if I can tell, the speed for going around moon is around 1600 kilometers per second. That is a huge speed. And when we have to land on moon, if we use the same speed, then it would just be a crash landing. Okay, so we cannot do that. We have to do a soft landing, which means our velocity should be 0 at the time of touchdown. So this is a huge task of reducing the velocity from 1600 km per second to 0, and within a matter of some minutes. So that is a huge task and a huge challenge for the scientists and engineers at ISRO. So we were on course, but due to some communication failure, we could not do that exact soft landing. It was a hard landing, and the lander never released the rover. So that lander and rover thing could not be realized. But the moon orbiter, it still continued taking pictures, and it is still operational, we can say, and it is still taking pictures. And actually this orbiter was very useful during our Chandrayaan 3 mission. We could communicate with the help of this orbiter. So because we were not to give up with that small failure, so in 2023, 14 July again, the Chandrayaan 3 mission started its course, and then after 1 month, actually it started from 14 July and it reached moon orbit around 5th August. So after that, there was this landing and roving, and we all know that on 23rd August we could land, that is a soft landing could be made on the moon surface, and later release of the rover, which worked for 12 days during the lunar day. But it was not made for withstanding the lunar night, which is a very cold affair, and so the battery died down, and we could not revive the battery again when the next lunar day came. Okay, so this was the idea. So now moving forward. So Chandrayaan 1 is as you can see, the Chandrayaan 1 was launched in 2000. The plan was from 2003, and then the launch was 2008 in October. And you can see in 2008 already that program came to an end after reaching the moon orbit, because it accomplished all its objectives. So the program was ended in 2008 itself. And the various and what was the biggest point of Chandrayaan 1 is that it carried a lunar impact probe, which was nothing but a crash landing on the moon, as I told earlier. So that was the all the Russian lunar programs, they were doing this crash landing only with the impact probe, and India's Chandrayaan 1 was also having a MIP, that is moon impact probe, and it could and because of this impact only, we could confirm the presence of water molecules on moon surface. Okay. So now going forward, this picture here you can see the Chandrayaan 1 spacecraft in actual view, and at the time of liftoff, we use PSLV rockets. At the time we used PSLV rocket, that was the strongest rocket, so you can say that was our most powerful rocket at that time. We used that PSLV. And here one thing is there that many people say that maybe some of you may know that at the same time India launched Chandrayaan 3 in July 2022, but Russia also launched Luna 25, and that was in August, and it was supposed to reach moon before us. So some people may say, and actually unluckily for them and somehow luckily we can say for us, for ISRO, it could not do a successful landing on the moon because it missed its proposed orbit by a few kilometers only. So it was a failure for Luna 25, but then some may say that it started in August itself and it was supposed to reach before us. Why is that possible? That is possible because they use, the simple answer to is that they use much stronger and more powerful rockets so that they can go directly to the moon. So the time of travel is much less. For them it was supposed to be only 15 days like that. But for India it is as you can see 22 to 23, it is exactly 1 month time. So why we need that much time? Because we use because we do not have as much money as the Russian and the Americans have, so we spend money judiciously. So how do we do that? We take help of gravity. You will be amazed to know that in the space the gravity is a great aid for all the space missions. What can happen when in space you just see that Earth is also pulling us with the help of this gravity. Moon also has little bit of gravity, so we take help of all this gravity and also the rotational motion. So whenever some body is rotating around another body, suppose this Chandrayaan 3 is rotating around our Earth, then it is getting a force because of this rotation. And if we can use both this rotational force and the gravity force, then we can slowly go away from Earth and still be included in the Earth's gravitational field. This process is called orbit raising. That is, we increase our orbital height. That is, we actually go at a time from further and further from Earth and still be in Earth's gravitational field. In this picture, in this slide, if you see, so initially after launching, we acquire the initial orbit IO. But after that, with the aid of this gravity and this rotational force, we slowly increase our orbital height and reach EBO 1, that is earthbound orbit 1, and slowly 2 and slowly 3. So in each of this stage, we have to reach and acquire and then be stable for few days. Then only we can make the next move to the next orbit. So in this way, after only we reach the EBO 4, earthbound orbit 4, then we started the translunar orbit or lunar trajectory. There we tried to acquire and we acquired. After that, once we reach the near moon, then the job is to reduce the orbit slowly to land exactly on the moon. So that is how we say initial lunar orbit and then lunar orbit 2, 3, 4, and then finally the operational lunar orbit, which is nothing but 100 cross 100 kilometer. That is, we are always in a circular orbit around the moon 100 kilometers away. Okay. So when we achieve that, that is, we say we are ready for landing. So India acquired that stage on 5th August 2023, but it took some more time for the actual landing. So Chandrayaan 1 had so many scientific payloads. You can see this picture. There were so many things, but then mostly these were for energetic particle study, because in space there are so many energetic particles from sun and other extraterrestrial objects. We are getting so many energetic particles. We try to measure those things. Okay. And on the way to the moon, Earth, we can obviously, if we put a camera on any Chandrayaan mission, then when we will be going towards moon, we can take a picture of Earth and a picture of the moon also. So these pictures, one is taken from Chandrayaan 1 from the Earth for the Earth picture, and on the right hand side you can see the moon picture. Okay. So now this material composition, this is maybe too much scientific, but only we can say, look at the blue signs. The blue are the areas where water is more there, or there may be some water presence. That is a material composition of the moon. So we can say that in the polar regions, the more chance of getting water. That is why India chose the southern polar region for landing the Chandrayaan 3. So the moon impact probe, that is supposed to reach the moon by a crash landing. This is the impact probe design. As you can see, scientists are working. Okay. So now how the moon impact probe actually works, it reaches the 100 kilometer by 100 kilometer, and then slowly it increases its speed. It increases its speed so that the moon's gravity also aids for it to reach moon and actually do a crash landing. This is how it works. So our moon impact probe also impacted the southern pole of moon. So Chandrayaan 2, from Chandrayaan 1, Chandrayaan 2 was the basic idea was the soft landing, as I was telling, okay, and this had more advanced sensors for getting more knowledge out of the moon surface. Same, it was configuration was one launch vehicle was there, but here we could use our more stronger or more powerful launch vehicle, that is GSLV Mark 3, and for Chandrayaan 3 also we used a similar. And then there is an orbiter. As I told, there is a orbiter that is moving around the moon, there is a lander and there is a rover. So our lander name is Vikram and the rover name is Pragyan, which is nothing but a robotic vehicle which will walk on the moon. So glimpses of Chandrayaan 2 you can see in integration stage. There is a clean room in the left hand side picture. As you can see, everything is getting assembled so that it is a clean process, okay. And this picture basically shows all the different journeys or for the different countries moon missions. And for the Russia we can say there is the Luna missions, that is in the red, and for China it has also come big way. China Chang'e and Chang'e 5 and 6, those missions are there. For America these are the Surveyors and Apollo missions are there, okay, fine. So now reaching moon orbit, here is one animation for all of you. As I told, slowly there is a orbit raising, and then once that proper orbit is reached we go for moon so that we can catch the moon, because the moon is also a satellite for Earth, so it is also moving around us. So we send the Chandrayaan in such a time, in such a place, so that it can reach the moon sufficiently. Okay, so now after this what is there? So challenges, what are the challenges in lunar landing? One of the main point is that the precise injection of the spacecraft in the orbits. When we say precise injection, these orbits that we are talking about, these are imaginary, but there is no line of guidance there, but we have to always be on the exact point by knowing by the spacecraft system. There is a continuous monitoring process. If we deviate by even by 10 kilometers, 20 kilometers, then we can never go to the next stage, because we are already lost. This was the margin by which Luna 25 missed, okay, and it failed, as we say. So after that there is this acquiring of trajectory or orbit is very important, and then there is a collision free separation of the moon Chandrayaan, whole Chandrayaan 3 mission from the launcher, because the launcher is just the rocket. We have to release it properly in the space. That is one of the challenges. And there is a precise trajectory also, because it is a 4 lakh kilometer long journey. So on the whole journey we need to maintain our track precisely. And as I told earlier, the landing is the most difficult challenge, because we have to slowly reduce our speed from 1600 km per second to 0 in 20 minutes. You can see that much huge amount of braking is required. So how that is acquired, that is the biggest challenge actually. So Chandrayaan 3, we are now going to the exact right topic, the Chandrayaan 3, what is there in Chandrayaan 3? This is one interesting topic. So there is one propulsion module, and there is one first LVM-3 is the launcher, that is the rocket that we are using. And then there is a propulsion module, there is a lander module, there is a rover module. Now what is the propulsion module? See, as I told, after the Chandrayaan 3 is separated from the launcher, that is the rocket, then it has to go in different orbits. It has to acquire the different orbits and then maintain the orbits and then slowly go for the lunar orbits like that. So all those things are job of the propulsion module. And even after reaching the moon, this Chandrayaan 3, there is a speciality, there's this mission, the propulsion module will not stay with the Chandrayaan whole mission. It will come back. Actually, it has already come back in 2023 November only, and it is now moving around the Earth. So it is doing a Earth observation work now. So after this, there is a lander module, as we already discussed so much. The lander will do a soft landing on the moon surface. It also carries some sensors for doing some research on the moon surface where it lands, and then it will also carry within itself the rover, which is the robotic vehicle, and it will be released after a soft landing. The rover will walk on the moon surface. Okay. So now what is the lander carrying? The lander is carrying one Langmuir probe that is called Rambha LP. This Langmuir probe is because all the planets, Their gaseous stage, there is ions and electrons, those are freely moving there. So in this stage, matter has 3 stages, as you know, water, gaseous and solid, but there is a 4th stage also, which is called plasma. The sun is actually in the fully plasma stage, but our planets and even outside Earth, there is a region of ionosphere, that is also plasma. Similarly, in all the planets there is some plasma. So this Langmuir probe is for studying the plasma nature near the moon surface where the lander is landing. Then there is CHEST. CHEST is nothing but Chandra's surface thermophysical experiment. So it will study how the thermal structure is, and actually it has given quite interesting results, that from the surface down there few meters below, how the temperature drastically reduces from the initial days of observation. And then there is a ILSA. ILSA is instruments for lunar seismic activity. Similar than earthquake, in the moon also there is a moonquake. So for studying this moonquakes, there is this instrument. And then there is a laser retroreflective array, LRA. This equipment we have got from NASA, and this is actually working as a fiducial marker. In a picture, if you sometimes you see one item is there, and then for getting a reference, you put another sometime you put a coin or something, so that you can get an actual idea how big or small that item is. So LRA is doing the similar job. So now the rover is also having, it is mostly the rover have whatever equipment the rover is carrying, it is carrying for the material composition analysis. So it is having mostly 2 equipments, 2 sensors. One is alpha particle X-ray spectrometer, APXS, and the LIBS, that is laser induced breakdown spectroscope, for doing the actual mineral composition of the moon soil, the regolith we say, the moon soil, for getting the actual material composition. And actually very interestingly, the recent result from APXS has been released in Nature magazine. Nature is a very renowned magazine. It has published one of the findings of the APXS very recently. All of you curious can go to it and see about what is the findings. Okay. So moving on, so as I already told, there are so many challenges because the spacecraft has to perform actually in the space, but so that it can perform smoothly, we have to do rigorous testing on ground. So how the testing is done, and so many numbers of simulations are run so that it can actually work in the space environment. It is a huge job, and this is the most tedious job and the most important job in any space missions, and especially for Chandrayaan-3. And so Chandrayaan-3, some glimpses we will see. So this was the integration stage, and in the rightmost picture you can see a vehicle is carrying the nose cone or the topmost part of the rocket. Here actually Chandrayaan-3 is situated in the topmost part. This is the time of launching, integrated and ready in the right hand side, and then at the time of liftoff in the center picture, and in the right hand side you can see while it is starting its journey. Okay, beautiful pictures these are. So now Chandrayaan-3 journey to the moon we have already told, and this is actually the chronology how it has been achieved. So it started on 14th July, and by 31st July we left Earth. As July ended, we left Earth's gravitational field and we were going towards the moon. And by 5th August we actually reached moon lunar orbits, and but then after we spent there some time, and by 23rd actually was the actual touchdown. Okay. So now in the landing phase there are braking phase, hovering phase, and then touchdown, because we have to do braking. As we told, lots of amounts of braking is there, otherwise that velocity will not reduce. But then still after that we have to hover for a long time to find the actual good place to land. Okay, we used lots of algorithms and used the AI, artificial intelligence also we took help of, to find the good place for landing, which is free from craters and other things. Okay. Yeah, so you can see that how that hovering slowly it is happening. It is slowly moving. It is very fast, but then it is actually the hovering thing. And then when the touchdown happens, it is actually touching the moon surface. Okay, fine. So now this is the Chandrayaan-3's post-landing scenario. We will show some pictures. This is the lander after it has made the landing in the right hand side, and in the left hand side is the lander. In the right hand side you can see the actually when the rover is getting separated. So rover, you can see the wheels, and the solar panel is the vertical thing, that is with the help of the solar panel this vehicle gets its energy. So in this picture also Vikram, that is the lander, as seen by Pragyan, that is the rover. So both the lander and rover has cameras and they are taking each other's pictures. Lots of pictures were taken. So these are two sample pictures. So as you know, the Prime Minister, Honorable Prime Minister, has declared the point of landing of Chandrayaan-3 as Shiv Shakti point. In this picture, we have tried to show on the moon surface the Shiv Shakti point. In the left hand side, you can see the landing site and also the marks created by the rover Pragyan on the moon surface. These are historic and emotional moments for ISRO and all of ISRO community. We also wanted to share with you. Chandrayaan-3 returns toward the propulsion module. As I was telling, it has actually came back to Earth orbit in around November 2023, and it is now moving around the Earth for getting pictures of Earth. And for Chandrayaan-3 mission, more important information you can find from all these sources. Okay, so in ISRO site is a pool of information where you can get all the information, and in other social media accounts where ISRO is sharing all this information, you can get. Okay, thank you all. This was about Chandrayaan-3. Now I will be coming to Earth and we will be going to our dearest state of Meghalaya. And in Meghalaya, what is there? So for the space community, we are there in Meghalaya and we are working as Northeastern Space Application Center. If you ever travel to Umiam Lake, near Umiam Lake, you can visit Northeastern Space Application Center where we are doing ISRO's work. We are representative of ISRO in Northeastern region, but our work is application for the users. So whatever scientific missions we are doing in the space, it does not directly connect to the people on the ground. So, but there is ISRO's role is mostly to connect to the people and serve them. So how can we serve them? Suppose I will give one explanation and one example. Suppose you are being made the chief minister of a state. Suppose you are chief minister of Meghalaya. Now you have to serve the whole Meghalayan people. So how will you do that? So for doing that, you have to plan. You have to plan for, suppose, what are the problems of Meghalaya. One of the problems, as we know, is the road connectivity is a problem for different areas. You know, water scarcity is there, though there are lots of water and it is raining very heavily. So, but then still we are not able to stop the water to get enough water for different regions. And also there is some scarcity of power. So every year we fail this scarcity of power. So you are ridden with so many problems that we need power, and there is a famous congestion of the Shillong city. So all this urban planning is also very much required. So who will solve these problems for you? As a chief minister, who will you look forward to? You will have to look forward to Northeastern Space Application Center for giving you all these solutions. And how NISAC does those? NISAC, with the help of ISRO's other satellites which are taking Earth's picture, they take satellite images and do some value additions. This NISAC is doing value addition on Northeastern images of satellite images and then giving the products to the state governments like Meghalaya government, like Assam government, and all the state governments of Northeastern region for their planning for development in different thematic areas. Like we are finding where are the where forest gap is there. We are finding where crops can be generated more and where maybe there is a suitable area for cropping. We are finding those areas also. We are finding where the road connectivity is there and where are the gaps and what are the suitable places for tourist places. So we are finding all those things and we are doing all these thematic works, and we are also finding the minerals. With the help of this space technology, we can also find where are the minerals. We can find which are the legal mines, which are the illegal mining, where it is going on. We can give all those information to the state government for helping them. So I will be coming briefly to those things. These may be too much for you, but we will start with this. Okay, so our beautiful Northeastern region, so what does it comprise of? It has 8 states. It is having 8% of the land area of the whole country, but just see the water resources. It is having 30% of the whole water resource of the country, and the hydropower potential is 44%. In the whole country, the Northeastern region possesses the maximum potential for hydropower, and as we know, Meghalaya also is dependent on hydropower. And so for this, we have some hydropower plants, but there is more potential. If we can effectively bind the water, we can get more power and our power scarcity of the state can be solved. There is a huge forest cover of 24%, and this forest is also the second biggest biodiversity hotspot in the world. So we have to preserve these things also, and these can be tourist destinations as well. Okay, so at NESAC in 24 years we will say actually. So what are our work? We work mostly in very specific domains like RS and GIS, that is remote sensing and geospatial information system, and there is also disaster risk reduction support is there, SATCOM, satellite communication application is there, atmospheric science is there, and also capacity building outreach, because whatever we do we need to teach also people so that they can do their own work, because we cannot do all the work for all the states. So we will also want to build capacity so that the people at the different states, they can do their all work on their own. So we are handling so many projects, total 131 projects are there, and there this is the division, you can say remote sensing GIS having the maximum number of projects, more than 80 projects, ICT governance having lots of projects, and in this according to this breakout you can see that there are so many projects in different thematic areas, and there are so many lots of new initiatives also, web-based lightning nowcasting, and then disaster management plan, forest gap analysis, bamboo resource mapping. Bamboo is one of the major resource of northeastern region. Then river atlas for mapping the water resource of the region, smart or model village planning in NER, and smart awesome, this is the application, mobile application, because the users, they want all the information at their fingertips. This is what is giving them the mobile app with all the information for geotourism, because for tourism these days people want all the information before they even start. So what is the place they are going, what are the things they can go, they can do nearby, what are the things they can see nearby, where will they stay in the night, what are the hotels and what foods they can expect there, what is the weather there, all this information with smart awesome they can get. And floods is very important, because flood is one of the problems of many states, one of the biggest problem of northeastern states. Assam is also bearing the brunt of this flood. So for them what we are doing one innovative program, that is a flood early warning system. So we run hydrological model and also weather forecast model to expect the rain that is supposed to come, and with that rain how much inundation can happen. We give this warnings to the state governments, to the SDMAs, that is the state disaster management authorities, so that they can do actionable outcome in time. Okay. So and we also have unmanned aerial vehicle which do lots of surveys, and they do lots of disaster management work also. So here you can see almost all the state government departments are our users. We work with all of them, and also with central agencies like Niti Aayog, and also Central Water Commission, Border Road Organization, Environment of Forest. This is the same list continuing, lots of educational institutes also we are interfacing with for capacity building. So the facilities, what we are having, so that we are doing so much work. We are, for all this work you can see based on computers, and we have to do lots of computation, so we need lots of computation power. We have a central computing facility, and we are also having an HPC, high performance computer cluster, and we are having good internet connectivity, so that with the help of those two we are hosting some services for the people in general, where they can surf a website that we have developed, and they can get all the information. The state government department, they need all those informations, so we have to reliably give them those services over internet platform. So those things we are doing. And we are also doing outreach, so we are having a beautiful outreach campus, and there are lots of courses actually throughout the year. Almost every time if you come here, you will find one course is going on. So this is how we are continuing our capacity building program. And UAV facilities, as we have told, UAVs are actually not exactly, you can say these are fancy things anymore, but these are actually very much needed, because for disaster and other applications, the scenario is changing drastically, and almost for every that is RS, remote sensing applications, we need UAVs these days. That is the term UAV remote sensing has come quite a big way. Okay, so we have lots of UAVs that we have also developed, we have assembled, and we use them for surveys. For all the state government departments requests we get for survey, we do all these surveys. In those surveys we take pictures, and with those pictures through a fly we can generate maps of certain areas, and with those maps some decisions can be taken by the state government departments. So the instruments, we are having a space and atmospheric science division, they use lots of field equipments for their different parameter retrievals from the field. So as you can say, lots of equipments are there. So the space applications that we do, agriculture, as I was telling, one of the projects, very important projects, is the SILKS, that is the Sericulture Information System. So Sericulture Information System is throughout the India, and Northeast NESAC is implementing that project. We are finding the suitable areas for silkworm. So that silkworm habitation, we are mapping the silkworm habitation areas and also finding suitable areas for expansion of those areas. And under this coordinated horticulture assessment and management using geoinformatics, there is a Chaman program. This is actually a mapping of suitable areas for the horticulture, that is for the different kind of horticulture crops. Also soil resource mapping is there. There is a space technology utilization for food security. Food security is very important for India because the population is increasing like anything, and we need food security for the whole population. So the food generation also needs to increase. So the district-wise soil fertility status mapping, because the soil is the main thing which is growing the food, so we need to find about the status of the soil, how fertile it is, and what is the potential of the soil. So all those things at NESAC we can do, and we are doing. And rice information system for the Meghalaya, we have already done so many projects for Meghalaya also. Okay, now going forward, for forestry ecology also, forest working plan, all the forest departments of the northeastern states, they have prepared their forest working plans with our help, because we have a foolproof methodology, and with that we can give the forest working plan, and from those things they can get the forest information. And also for at the help of different states request, we are doing the Jhum area mapping, and also forest fire is one of the major concerns for many states of northeastern region. We are mapping the forest fire area also, and the potential areas where the risk is more vulnerable areas for forest fire. Wetland change analysis, vegetation phenology studies, forest cover dynamic studies. So where forest cover is today, how it is changing, and if it is reducing somewhere, if it is increasing somewhere, all those we are trying to map. And then finally biomass mapping is very important, and bamboo resource mapping is very important projects for NESAC. In water resource, as I told initially, that water in a northeastern region is having 30% water resource of the whole country. So we have to map these water resources. We are doing those through river atlas. For Assam and many other states, we have already prepared and released the river atlases, so that the state government is knowing what are the rivers, what are the tributaries, where are those tributaries, and so they have at their fingertips all the water resource related information. Submergence study also we are doing, inundation mapping also we are doing, and also district level river atlas also we are preparing for different state governments. Okay, lots of works are there. And then geoscience, as I was telling, that we can find the suitable areas for certain minerals. We can find which minerals, what is the suitable area where the minerals can be. Certain minerals are very much required, and they are very precious, but sometimes those minerals can also get contaminated with water. That contamination is not necessary, and that is very much to be avoided. So we can find those contaminations also where arsenic or other potential pollutants can be. We can find those things. And landslide is one of the major disasters for northeastern region. We can find the landslide inventory and the susceptible areas also for early warning in northeastern region, the mineral targeting, and also the legal and illegal mining. So those aspects also the geoscience division is looking into. And the urban regional planning in Shillong city itself, we have developed a master plan, and we have submitted to the state government for reducing the traffic congestion, for finding alternate routes. And similarly in other states, we are looking for various projects of model village development, so that in the village, now these days villages grow on their own, and sometimes maybe unplanned way, but then we are giving them some suggestions how you can make a village more planned, so that the major benefits the people can get better way. So those things the urban planning, the traffic planning, the urban and regional planning division is doing with the help of UAVs obviously. And so in the IT and geoinformatics, it is one of the major divisions of NESAC. Here lots and lots of work we are doing. All the state government, they need the information of the projects running and the progresses at their fingertips. So we are developing dashboards for them so that they can get all the information at their fingertips, and even different apps we are also developing for different workers, health workers. We have developed this fever tracker app, for which we also got the patent. And then also we are doing the e-atlas. E-atlas is actually for the election commission for the different state. I will show you one picture of the e-atlas. There it is, the e-atlas that we are using in the Manipur state. So this is actually giving them whole over the state at the time of election, where are the EVMs moving, where are the people moving with them. They can map them, and they can, if any incident is there, the incident can be reported from the field, and that will be flashed on the screen, so that they can quickly send them a rescue team or a status report they can ask from the team. Okay, this is one incident of a actual real-time incident reporting for this e-atlas thing. So infrastructure connectivity, because the dashboard thing we have developed. So there, what are the is it just like the information that is on the field? No, there is also analytics. This analytics can tell us where are the gap areas, like where road is not there, where it is very far from the health facility, or well, some health facility may come up, so that it can benefit the nearby areas best. So accordingly, there is lots of analytics, and for this there is a specific portal, that is the Northeastern Spatial Data Repository. It, as the name suggests, it is a data repository. That is, it is a pool of data. Here you can find all the spatial data pertaining to the Northeastern region, and it is very much helpful to the state government departments, because they do not have to go to different places, or they do not have to request to us again separately give us this map, give us that map. All the maps is there, and it is real time updated, so they can just go there and click which map they want and download and use their map. Okay, this is a very good thing, and you can go to any SDR portal by searching in the net. You can get all the information there. UAV remote sensing, we are generating the maps. As I told, UAV surveys are being done by different state government departments for different activities. The damage assessment of Kopili hydroelectric project, it was a huge disaster, and our UAV team reached there first, and they could find out the actual reason of that, so that it could be mitigated. And also bathymetry surveys that can be done from aerial surveys. Also in Garo Hills district, village resource mapping was done. For crop health monitoring also, because these UAVs, they can fly at around 50 to 100 meters high. From there, if they fly over a affected field where some insects are damaging the crop, then we can map beautifully the areas where the crop damage is and which areas are still safe, and then maybe we can take action. The state government departments, they can take the action. Community reserve forest boundary mapping is also very important, so that also work has been done. Large scale survey and mapping is done, wetland survey mapping is done, and for the various, even we are working outside Northeast also at the request of the various state government departments. We are working as far as UP and Jammu and Kashmir also. Space and atmospheric science, because this area, there is some huge disasters that happen, and those are many times they are induced by rainfall, heavy rainfall. So we have to give nowcast and forecast for rainfall, and nowcast for various lightnings and other disasters. So our space and atmospheric division, they are doing lots of modeling and simulation, and they are giving us all this information, that the lightning nowcast and the rain forecast, which are getting assimilated with the IMD results. And then suppose you are getting in your mobile some message that heavy rainfall is very likely today, that is coming from IMD, but the data and the analysis is done by NISAC. They are giving to IMD, so that all the data are assimilated and then given in the form of a message for the common people. So SATCOM applications are also there. In the SATCOM application, the tele-education and telemedicine, because this area is still a remote area as compared to other areas of the northeastern or other regions of the country. So here education and health sector, they face the problem because of this remoteness. The people cannot go to the schools where all the facilities are there. Suppose all the district, they are not having proper schools or the proper hospitals. So the people in the far-flung areas, they do not get the help, real amenities of the hospitals or the schools. So what we can do, with the help of satellite communication technology, we can bring the good teachers or the good doctors to the remote areas. With the help of this connectivity, they can talk to the good doctors, the doctors can assess the patient situation, or the teacher can give a lecture. Like now I am giving you a lecture over internet. Similarly, teleeducation, suppose you are in a very far flung area where your school is very remote and classes are not happening that good, so then you can connect to teleeducation and you can get good study material from a teacher sitting in Shillong or in Guwahati. So in this way you can be benefited with the help of satellite communication technology. Also for internet services, because these days internet is everywhere, so how can we get internet over satellite? Over satellite is internet is also coming. GSAT-29 is ISRO satellite which is giving internet, especially for the northeastern region. This satellite was launched, J&K and northeastern region. Okay, so fine. Now in the SATCOM and UAV applications, there you can see that we are having that teleeducation studio. This is actually the studio in NESAC that we are having still. And the right hand side other pictures, there you can see the UAV's team has gone to different places. In 2022 there was a devastating flood there in Dima Hasao of Assam, and the whole rail line, track, everything was washed away. So our team reached there, they helped the authorities in rescuing the people. Similarly, it was happening in the Silchar also. So our team went there, they could find the actual breach location where from the river water was entering the city, and the state government could take necessary actions from that. So for NER DRR, because the disaster, we have specially prepared one node at NESAC which looks for all the disasters, and all the disasters information you can find at one place, nerdrr.gov.in. If you go there, then you will find all the disaster information, and even nowcast of lightning also, and the probable areas where heavy rainfall is there, thunderstorm is probable, all those information you can find from there. So because of the huge volume of work that we are doing, we are getting noticed, and we are getting prizes also. So for the year 2022 we have got National E-Governance Awards, that the silver medal, the second prize basically. In emerging technology adoption we got this award, and also different other awards for Rajbhasha implementation also we are getting. So with these things I want to conclude my series of 2 lectures. I will conclude here. I hope it helped you to understand first India's Chandrayaan-3 mission, and then what are the activities that NESAC is doing for the whole northeastern region. So thank you all. Thank you.
So thank you, Sir Anjan, for sharing your valuable insights on the space applications as well as NESAC's activities, which we were not aware of. Your presentation was really enlightening as well as informative, and we're grateful for your presence here with us. So your expertise has given us also a new perspective on the application of space technology with respect to our northeastern region. The topics that you have covered, application on urban planning, on biodiversity, forest covered areas, and many other things are all related to the school syllabus, and maybe some exploration on exploration and learning techniques maybe also be explored in later time with your organization. Thank you, sir. Thank you very much. Dear students, after witnessing all the demos, the presentations, are you fascinated by the wonders of the universe? Do you dream of exploring the cosmos and uncovering its secrets? We encourage you to pursue your passion for space exploration. To fuel your curiosity, we invite you to explore the following resources. Bharat on the Moon portal, which is a dedicated online platform showcasing India's achievements in lunar exploration. Students can access information, images and videos about India's lunar mission such as Chandrayaan-1, Chandrayaan-2 and Chandrayaan-3. The portal also aims to inspire students to learn about space exploration and India's contribution to it. Grade-specific special modules on Chandrayaan. There are 10 educational modules available in the National Digital Library designed for the students of different grades. Each module focuses on a specific need of the Chandrayaan mission, such as a spacecraft design, mission objectives, and scientific discoveries. So students can access interactive content quizzes and activities to enhance their understanding of the Chandrayaan missions. There will also be a 30-minute video on Chandrayaan modules. This video presentation showcase an online class based on the Chandrayaan modules. Students, you can watch the video to understand how to use the modules and also learn from these interactive content and activities. The video aims to facilitate student learning and engagement with these modules. Also, we have the NCERT e-magazine launch, which is an upcoming e-magazine from NCERT, which is centered around the space theme. The e-magazine will feature articles, stories, and activities related to space exploration and India's achievements in the field. Students can access the e-magazine to stay updated on space-related news and developments. Also, we have curated audio-visual materials. These resources from the Department of Space are available on Diksha and PM eVidya channels. Students can access audio-visual materials such as videos, animations, and documentations, or to learn more about space exploration and India's space program. The curated materials, they also aim to provide our dear students and teachers with engaging and informative content to enhance the understanding of space-related topics and India's achievements in the field, and which will increase the learning outcomes and inspire you to pursue career in STEM fields in general and space science in particular. Remember, our universe created by God and given to us is full of mysteries waiting to be unraveled. Your curiosity and passion can take you to new heights, so happy exploring. And now, as we near the conclusion of our webinar, we invite our esteemed experts to share their parting thoughts and reflections on the key takeaways from today's webinar.
Well, being a part of this occasion is being a part of the history of the nation. It's indeed a very proud moment to be celebrating the first ever National Space Day. And I remember last year on this day how we were all glued to the television, anxiously watching the landing, and we were looking at the data on the screen and how it was coming closer to the lunar surface, and even the velocity was decreasing, and we were being able to understand that yes, this is a soft landing happening, and finally it was successful. So all that excitement, all those memories coming back and being able to celebrate this certainly is a huge thing. And the other thing that I would like to touch upon before I pass on the microphone to my co-panelists is both of you have touched upon the fact that all of this technology is absolutely indigenous. Very little help has come from the West. We have gone to the West a number of times, excuse me, and I have been fortunate to be able to listen to lectures from directly the the top people in ISRO on a number of occasions at national events. And they have mentioned how on certain occasions when a launch failed, a rocket failed, and the entire satellite went down into the waters, there was an urgency to put up a satellite because the already existing satellite was nearing its life, the end of its life, and so we really needed to quickly put up another satellite. And we went to one of the Western countries. They told us it would take them 5 years to give the transponder, which they actually just put up a few months back. So that is the kind of obstacles they will put in our path. The kind of cost they were asking was 5 times the market cost. So without naming the country, irrespective, it was all across. And then the ISRO scientists took upon themselves, there was just a 6-month window within which this had to be, another satellite had to be launched. They did the research, they designed the thing, tested it, put it up, and everything was successful. These are some of the stories that come out of ISRO, and when they tell these stories, you can see what we today in our modern times understand by patriotism, the love for the country. Without that extreme love for the country, this kind of hard work, this kind of dedication is not possible. Yeah. Your thoughts?
Yeah, taking a cue from Rahul, I would like to say that Indians, when we are we are cornered, we come back, we bounce, and we really, excel. So this is a very remarkable year because we are celebrating the first National Space Day. At the same time, this year we are also setting up on the quantum mission. That is, ISRO put us in the space, and now the world knows that we are more or less the leaders in space. Now, the next thing is the chips. We cannot manufacture chips because the technology has been kept well guarded by certain countries. And yes, we have made chips which are a little bit bigger. Many of the chips used by ISRO are actually developed in India. But our limitation is these are all 180 nanometer chips, whereas IBM has already developed 2 nanometer chips. The standard size of a chip nowadays is about 8 to 10 nanometers, and that is what we strive. So we know that this is our chance, and if we could do it in space, we'll definitely do it with the quantum mission. We are very near to making our own quantum computer. Okay, TIFR is in the final stages of it. So, as students, we see a lot of Instagram reels and Facebook stories. But do we know that these things are happening? Please go to the ISRO website, the TIFR website, the IISc website, see what kind of amazing things are happening in India. We are a part of a revolution, a technological revolution that is taking place. But we need to realize that, slowly things are changing. We are not importers of devices. We are slowly trying to make them here, right here. One of the semiconductor hubs is coming in Assam. And if, the students of the region can tune to those technologies, the job opportunities are huge. So stop blaming and start preparing. That would be my message for all the youth who are watching this program. Thank you.
I would like to continue on what Sir Ayon and Sir Rahul had just mentioned to us. We as maybe people from the Northeast, we are a bit slow. I feel that science in this region is slightly backward to mainland India. So I encourage the students who are still young, to dare to dream. Just I would like to use a line that our president, ex-president, Dr. APJ Abdul Kalam used to say. He used to say that the dream is not what you see while you're sleeping. Dream is that which doesn't let you sleep. So I urge the students of this region, to dare to dream. Lots of things are happening, like Sir Ayon and Sir Rahul have just stated. And then don't be scared. Move out of your shell, and wish you all the best. Thank you.
Yes, it's really amazing to hear from all the three of you and all the various aspects that we have come through all the presentations. And coming to the classroom level, we see that what Sir had said, that it's not only science that can explore the space of science, but it's also other multidisciplinary subject. So we encourage the students to kindly go through the website. We have the DRT website, we have the ISRO website, we have the HCRT website, and we hope that with all these, it will encourage you more to study not only science, but beyond that, in order to understand what is around us, and also that we will be able to value what we have in our midst. So thank you for all the wonderful insights and reflections on these key takeaways. Thank you so much.
Thank you.
So I now invite our Joint Director, Sri P.B. Lartang, to express our collective gratitude to our experts and participants who are students and as well as teachers and others. So over to you, sir.
Thank you, Dr. Della. A very good evening to all. On behalf of the Directorate of Educational Research and Training, I am glad to express my vote of thanks as part of the program for celebration of the National Space Day. As we draw this enlightening webinar to a close, I would like to extend our deepest gratitude to all our speakers and panelists for sharing their valuable insights and knowledge with us today. Shri Ankush Kumar, Scientist ISRO, Shri Anjan Debnath, Scientist NISAC, Dr. Ayan Bhattacharyji, Professor NIT Meghalaya, Shri Donrich Karkongor, Assistant Professor, Department of Physics, St. Anthony's College, Shri Rahul Chatterjee, Assistant Lecturer, Jailroad Boys High School, Shillong. Your contributions, sirs, have made this event truly special and memorable. We are thankful to Dr. Della Gracious Sons, Associate Professor DRT, and her team for their hard works and dedication in organizing and putting together this webinar. To the technical team, your efforts behind the scenes have ensured its smooth execution. Special thanks to the students, teachers, and teacher educators as well who are listening and watching this webinar on social media, and for your enthusiastic participation and for making this event a success. Your presence and engagement are what make this event worthwhile. Lastly, let us make a moment to celebrate the incredible success of Chandrayaan-3 and the bright future it heralds for space exploration. May this achievement inspire us all to reach for the stars and continue pushing the boundaries of what is possible. Once again, thank everyone for making this webinar successful. Thank you.
Thank you, Sir Lartang, for the vote of thanks. We appreciate your esteemed presence as well as your guidance and motivation. So in conclusion, thank you to our esteemed speakers and our engaged participants for making this webinar an unforgettable experience. We hope you all found the presentation enlightening and inspiring. As we conclude, remember that space exploration represents the ultimate frontier of human curiosity and innovation. Your generation of students has the power to shape the future of space research and push the boundaries of what's possible. To our teachers, we appreciate your dedication to inspire and educate the next generation of space enthusiasts. Your role is vital in fostering curiosity, creativity, and critical thinking. Continue to ignite the spark of curiosity in your students and empower them to reach for the stars. Thank you again, and we wish you a wonderful day ahead with wonderful discovery. Thanks and God bless.